Hello and welcome to KAUST Live. We're coming to you from the Red Sea Research Center Symposium on Marine Plastic Pollution. And here to talk to us today about that is Carlos Duarte and Julia Reisser. Thank you both for joining us so much.
Yeah,
Thank you for inviting us.
So Carlos, get us started. Tell us a little bit about the symposium.
So my research group has been working on marine plastic pollution in the Red Sea, but also globally, but recently on the Red Sea, and then we have a number of new findings that we would like to share. And as this happens, then also we have the pleasure of hosting Dr. Julia Reisser, that is a postdoc between the Australian Institute of Marine Science and KAUST, and she comes just returned from an expedition in the Pacific where they have been surveying particularly with a focus on large marine plastic. So we thought that the three results together would make a nice package to communicate to the public, and also at a time where the awareness on marine plastics has been a global problem that we need to take action on, has reached a tipping point. And we have now a number of announcements being made by countries and companies in terms of taking action to prevent this from continuing to harm the oceans. Right. So we like to share all of this with the KAUST community.
Right. So Julia, then get us started. What is the big picture problem with marine plastic pollution?
Yeah, so nowadays we're using plastic for many things. It's a very useful material, so it's all surrounding us here. But it seems that one of the issues is we're struggling to reuse that plastic. So we have a huge production of plastic, but also a huge waste coming out of our use of plastics. And unfortunately, the ocean is downhill from everywhere on Earth. So a significant proportion of the waste, the plastic waste we are generating, is ending up in our oceans. And it's having an impact on the animals that live there, also in our economy, because it makes, for instance, a beach look less attractive for tourists. It can also entangle on propellers of vessels. And it potentially also has a human health problem. We're still quantifying and trying to understand the problem, but the plastic has some substances, like plastic additives, as well as pollutants that are absorbed into the plastic when it's into the ocean. And it seems that these pollutants on the plastic could be contaminating the marine life, including our seafood.
How is it polluting? Are they ingesting it? Does it pollute the environment? Talk a little bit about that.
Yeah, so the plastic materials, once they get into the ocean, there is two sources of the chemicals that we're finding on the plastic. The first one is what we call the plastic additives. When we make the plastic objects, we have the polymer, but we also add some substances to this plastic to make it, let's say, more resistant to fire, so flame retardants, or to make it more flexible. And some of the substances, we're not 100% sure if they don't have any consequences for human health and also the ocean's health. And the second thing is, once plastic gets into the ocean, it acts like a sponge for what we call persistent organic pollutants. So if our oceans is already polluted, some of that pollutant will get attracted by the plastic. So that's a second source of these chemicals that we found on the plastic. And we're still researching it, but there is a chance that once a fish or any animal eats the plastic, a portion of that pollutant can go into the animals. Therefore, that pollutant could potentially get into what we call the marine food chain.
Carlos, you've been around the world in all of the oceans. How big is this problem? Is it everywhere on the planet?
Well, so in 2010 and 2011, I led a circumnavigation expedition around the Earth that took oceans, that took 9 months. And in that expedition, we were collecting plastic samples along the way. And we produced the first global assessment of marine microplastic loads. And then we found that accumulates mostly in 5 areas that we call the gyres, which are the central areas of the ocean where materials that are transported by currents get entrapped, and those are in the tropical and subtropical regions. So the load there is particularly high. And then also we conducted 2 subsequent surveys in semi-enclosed seas, one the Mediterranean, where we also found very high loads of microplastic, and the other one the Arctic, where we found, we completed a circumnavigation of the Arctic also, and we found very high loads of plastic in the Norwegian and Russian Arctic, and that is delivered by global current systems into the Arctic. That is the terminal station for all of the microplastic that is transported in the ocean. And yet, when we evaluated the amount of plastic, we were surprised that the amount that we found floating in the ocean is much less than expected based on estimates of how much enters the ocean. So that means that there are sinks of plastic. So it might seem to be a good news, but in fact it's a bad news, because that means that we don't know where the plastic that enters the ocean is. And then we've been busy since trying to understand and detect these sinks for plastic in the ocean.
A few statistics from UCSB research is something on the order of only 9% of plastic globally gets recycled. 10 million tons of plastic waste annually makes its way into rivers and oceans. I mean, this seems like a daunting problem. How do you even start to address this?
Yeah, I think the problem is not really in the ocean. The problem is in the markets and the way we design products and how we package products. So if maybe, as Julia was saying, plastic is very useful and very practical material, but we have probably gone overboard in using plastic. So now when we walk out of a supermarket, then we carry all of our food wrapped in plastic. So where we might be concerned as consumers as to how much plastic we might be ingesting from, let's say, the materials that get into the food web in the ocean and eventually we consume them, that is probably nothing compared to the plastic that we accidentally consume because we insist in wrapping up all of our food in plastic. So I think we need to pause, think about our behavior as consumers, and start replacing all of that plastic by other materials that are friendlier to the environment and friendlier to the oceans and friendlier to our health as well.
Carlos mentioned gyres. So tell us a little bit, Julia, about what gyres are, and then your experience with a particular group going to these places and actually gaming up solutions for how to collect the plastic.
Yeah, so I had the pleasure to work alongside a foundation called the Ocean Cleanup. And their main mission is to develop technologies to try to mitigate the problem on the ocean. And the young entrepreneur that founded this foundation called Boy and Zlat, he set up as the first mission of his foundation to remove plastics from what we call the Great Pacific Garbage Patch. And this is one of these 5 what we call accumulation zones on the oceanic areas or garbage patch that Carlos was talking about. And the one in the North Pacific seems to be the highest one. First of all, because of oceanography regions, we have like this very clear circulating pattern that pushes some of this plastic into the middle of the Gaia. And secondly, because nowadays we have most of the plastic that's flushing to the ocean, it's quite concentrated in Asia. So that plastic tends to lead towards the Pacific. One thing that we learned by doing some expeditions into the area that we call the mega expedition, and then after we did an aerial expedition where we revisit the area with an aircraft. What we learned with this expedition is not that every plastic ends up there. It's just a very specific type of plastics. So the plastics we got, they are very thick. They have a very high volume, which allows them to persist at the sea surface for relatively long period of time. And so like, for instance, buoys and fishing crates, this type of thing, they are very thick, hard plastics, and they end up in this area. And then we found lots of fishing gear, including what we call ghost nets. There is lots of fishing nets coming like from Alaska and Asia, and they get into this area. And the circling patterns of the currents make them catch each other, and they start to form like a bundled bubble of nets that can be, like, one item can weigh a ton. And that was quite surprising for us to learn that about half of the mass on this garbage patch are actually made of this fishing gear. So that was very interesting finding from this research that was founded by the Ocean Cleanup.
So the plastic just sits on the surface and you can collect it, or does it descend into the ocean column? Talk a little bit about that.
Yeah, so right now the Ocean Cleanup is focusing on mitigating the problem at the sea surface. So that's one of the hot spots where the plastic accumulate. We also have on coastlines and canyons, but at this area we also have lots of plastics, and so the engineers are developing technologies to collect some of it, and they're using booms that are similar to, it's like a pipe, and are similar to what's used when you have an oil spill into the ocean. So they float into the ocean, and then the plastic encounters that barrier and they stay in front of it, and with time you start to have an accumulation of plastic there, so you can take your vessel there and take it out of the water.
So the gyre acts as a bit of an engine to collect this almost for itself in a way.
It's pretty much it's a very simple system. So it's like a pipeline with a screen, and what brings the plastic is actually the ocean current. So there is no propeller or anything. It's just like a pipe that you deploy in the ocean, and it drifts similarly to the plastic, but a little bit slower than the plastic. So the ocean current itself, it's going to bring that plastic in front of that pipe.
Right. So that covers open ocean, but as you said, coastlines. Carlos, what happens when it gets to these coastline environments?
So I believe the estimates is about half of the plastic that enters the ocean through rivers or wind or something sinks into the ocean sediments or marine sediments, and another half is buoyant and then gets dispersed into this oceanic transport. So the component that sinks also accumulates in particular areas, so it can accumulate in the surf zone in coastlines, and we find very high loads of plastics in some remote islands here in the Red Sea, but also now, sadly, to find a place full of plastic is almost an element of pristineness, because when you go into the farthest place in the middle of the ocean that no one gets to is full of plastic because there's no one to remove it. So it gets everywhere, and then once it reaches the sediments, then they accumulate sometimes in very large masses. So of submarine canyons, the plastics get transported through the canyon, and at the end of the canyon then they accumulate, forming like mountains of plastics, like one that was found by a submersible of the city of Marseille that is several meters tall and about 200 meters wide, full of plastic material that just accumulates at the end of the submarine canyon. And some of these plastic fragments and then gets buried in the sediments and may persist there for millennia or longer.
What effect does it have on the flora, on the plant life itself?
Well, so as Julia mentioned, the materials that the plastic have and the plastic itself is harmful to marine animals, from very small crustaceans to large whales and sharks, because it might clog their digestive system, but because it also leaks pollutants that might harm the organisms. But the plants are not very much affected by plastics or the associated pollutants, and yet plant communities in the ocean, like mangrove forests like we have here in the Red Sea, or seagrass meadows, may actually act as traps for plastics and then put them down into the soils and sediments and get them out of circulation from being transported elsewhere in the ocean. So they don't seem to harm plants, as at least I'm not aware of any evidence that there's any harmful effect on plants, and yet plant communities that have this role as sinks, they can remove them from the oceans and play that role of cleaning up seawater from plastic.
So it's another benefit of leaving the mangroves there.
In fact, we're quantifying this. We're quantifying this, but it's a tedious process because we have to sort sediments and soils to find out the tiny amount of plastics. But we're currently quantifying the burial of plastic in the Red Sea, in the Arctic, and also in the Arabian Gulf.
Yeah, that's an interesting question, right? So the Red Sea is sort of an oddly shaped body of water. What do you find actually happens with these plastics in the Red Sea?
Yeah, so in the Red Sea you find lots of plastics on the shore, of the Red Sea, but that again is a sign, at least in the Saudi sign, is a sign that it's a pristine coastline. So there's no tourism, there's no developments, there's no one around in the islands and beaches, and therefore the plastic has accumulated over decades. So we find a lot in the shore, but when we take samples in the open Red Sea waters, then we found the Red Sea, and we were surprised to find that the Red Sea has one of the lowest loads of floating plastics anywhere in the world. But because of the oceanography, that it receives water from the Indian Ocean, but that is at dead end, then we would have expected that there will be high loads of floating plastic, so we were surprised. And we believe that the reason why the loads are so low is that much of the plastic is being trapped in the mangroves on the shore, but also by the coral reefs, because these organisms in the coral reefs are filter feeders, and they can remove particles of the size that is characteristic of microplastic in the ocean. So we're also looking at this role, at the role of reefs as filters for marine plastics in the Red Sea.
Fascinating. So what do you do with this mass of plastic once you remove it from the ocean, from the mangroves, whatever? Julia, does your work, has that included that at all?
Yeah, so at the Ocean Cleanup we also have what we call a recycling department. And the idea, the business model that the Ocean Cleanup wanna build upon is to take that plastic that probably was like single-use plastic, or didn't had a long life, and then transformed into things that are available and that people might pay high amounts and could actually fund the cleanup. So they're looking at, for instance, building ocean plastic sunglasses and watches and things that can be made of the main polymers we find, which is polyethylene and polypropylene. And yeah, there is other companies doing some great work on that. Like there is another foundation called Parley for the Ocean, and they are already successfully collaborating, let's say, with Additives. They are doing ocean plastic shoes that are very popular and selling very well, and also doing some sports shirts and things like that. So yeah, there is lots of people looking into that and trying to make something that's said, looking more hopeful and give hope to people and energy for us to start to look more into upstream solutions as well, which at the end of the day, it's what's going to solve the flow of plastic that's going into the ocean.
Right. Some might say that making it another consumable maybe just continues this cycle. How do you feel about that?
Yeah, I think you just need to be careful with which type of item you do. And I think the main value of doing an ocean plastic, let's say sunglass, is just people get aware of the problem and energized to make something about it. Because I think, at least me coming as an academic, I think we tend to just give like lots of bad news to the public. And I think it makes people feel helpless, and they like, I would just stay here on my sofa and doing whatever. But when you try to create some positivity out of a problem that seems unsolvable or too overwhelming, actually also help to solve. So I just think okay, you cannot take ocean plastic and do, I don't know, plastic straws or things that we actually wanna bend.
Yeah.
But do objects that actually, are needed, like a sunglass or, I don't know, the cover of a laptop, or, the things that we actually need plastic for.
We've talked a lot about plastic, but I'm sure that there are other types of pollution in the ocean. What are those, and in what amounts do they come? Is plastic the vast majority of the problem, or how do you see it?
Well, plastic is the most visible problem, because they are, even when we talk about microplastics, there's still a few millimeters, and many of them you can see them with your naked eye. So it is a manifested problem in that you can see it. Whereas most of the pollution in the ocean comes in the form of persistent organic pollutants that Julia was referring to earlier. And they come from all kinds of sources, and many of them are semi-volatile. That means these are compounds that can either be up in the atmosphere in a sort of gaseous form, or they can be dissolved in water or trapped in soils. And these materials are very persistent, and they're small molecules and very harmful, because they can affect the immune system of organisms. They're cancerogenous, so they have a range of negative effects. Some of them also even harm the ozone layer, right? Right now there's a new decline of the ozone layer because some new chemical is also now harming the ozone layer. So these chemicals, we cannot see them, but they're everywhere. And there's a process called global distillation, through which these semi-volatile persistent organic pollutants then are in equilibrium between the ocean and the atmosphere. So they enter the ocean or soils, then they get released again, and they are hopping and shifting up to the poles, mostly in the northern hemisphere, because that's where most of the pollutants are produced. So they end up through this process, they end up being transported to the Arctic. And to the extent that the Arctic sea and ice and snow is actually loaded with these persistent organic pollutants, and Arctic marine life, particularly belugas and polar bears, are the most polluted animals on Earth. Whereas in the Arctic there's very little of these products are being manufactured in the Arctic, but they end up there through this global process, and this we cannot see. And recently we also, in the same expedition that we quantified plastics, then we quantified how much polycyclic aromatic hydrocarbons were entering the ocean. So these are products that are released through the combustion of fossil fuels that are not totally burned to carbon dioxide. So these are extremely harmful for all kinds of organisms, including humans, and they also enter the ocean through the atmosphere, all around the ocean. And we quantify that every year there's about the equivalent of 20 oil spills comparable to the one that happened in the Gulf of Mexico a few years ago. That was the largest oil spill on history. So every year 20 times as much enters the ocean through the atmosphere everywhere.
Wow.
And that's a lot more in terms of mass than we see it in plastic. But the plastic is tangible, the plastic we can see, and this other pollution is hidden, and we can only detect it with very advanced analytical systems.
So in a way, the ocean is quite symptomatic of a number of other problems that we're creating on land in a way.
Yeah.
Yeah, and I think like the plastic problem, like lots of people are concerned about the chemical impacts of the plastic, and then we need to realize if we want to solve that problem, we need to tackle what Carlos was talking about, the persistent organic pollutant. Because if we stop releasing so many dangerous chemicals into the ocean, and we make sure that the plastic we produce do not have chemicals that can be harmful for us and the ocean, then you kind of solve that problem. So you know it's all interconnected. Like I collected that plastic from the garbage patch, you know, I found the PHAs that he was talking about, PCBs, PBDs, and they are there because the ocean has it, and because the plastics we're producing, the only person that really, like the only people that really know what's in some packaging, is the industry that they are producing it. So I think all this movement towards solving the plastic pollution problem, we need to realize that, you know, the persistent organic pollutant problem is actually very connected to it. So if we start to produce safer plastic products, which means we know what's in there and we realize that the plastic interacts with our food, like it leaches things, and then we also take care more about what we're releasing into our oceans, then we're going to solve that the most concerning part of the plastic pollution, which is that chemical impact that the plastic is potentially creating in our oceans.
What is the future if you look 10, 15, 20 years into the future? What is the future research that's going to have to happen or that will happen in the resolution of some of these challenges?
Well, so as Julia was mentioning earlier, there's already efforts to clean up the plastic that is already at sea. And I think just this week one of the devices was placed in the ocean, so there's hope that we can clean the plastic that is already in the ocean, but I think really the solution comes through replacing plastics by other materials, and we need to step up our efforts in trying to find alternative polymers, and polymers that can replace plastics for single-use that are not creating other problems, because there's been some polymers produced from vegetables, but then producing those required a fertile land, require water, and eventually compete for food with us. So one possible source might be marine macroalgae or seaweed that are a likely size source of polymers that might go some ways into replacing plastic without generating either problems on the environment or problems on the food market either. So I think we need to do a lot of research on new materials that will replace the plastics, and also using simple existing materials like paper bags instead of plastic bags. So there's already solutions that are ready, but at KAUST we have one excellent research program on polymers, and I hope that that program is going to come with a polymer that will be sustainable and safe, that will replace plastics.
Yeah, and that would help lots already, because about half of the plastic we produce nowadays goes towards single-use packaging. So if we find a solution there, like we already decrease the amount of waste we produce, we make safer the packaging we use on our food. And,
it's not only a solution for the environment, but it's a good business opportunity, because, for instance, in the European Union, there has been a bill passed that by 2020, which is around the corner, single-use plastic will be forbidden, banned for the whole of the European Union. So any company that comes up with a material that is useful, cost-effective, and free of problems is going to have a sweet market to place their products.
So that's a good plug for someone's startup, I guess.
Yes, new entrepreneurs there.
Exactly. Well, thank you both so much for speaking with us. This is a fascinating topic, and best of luck with the symposium. I guess that's just happening today.
Yeah, in half an hour or so we'll get going.
Very good. Very good. Well, thank you both.
Thank you very much.
And thank you to our online audience for joining us. You can follow Julia and Carlos on Twitter, as I do. And please remember to follow, like, and share all the KAUST official channels. That's all for right now. Thanks.